The question I've got says, find the derivative of the function f of x, which is equal to x squared minus 3x plus 12 by first principles. Okay, so when I see first principles, I think of this picture where you've got x and it's got a function value, and then you move a little bit and it's got a function value, and then you figure out this slope here, which is made by dividing this distance by this distance, and then you make the h go towards 0 so that these two get closer and closer together, and that line gets closer and closer to being the actual slope of the function. And so first principles would be f dash x is the limit as h goes to 0 of this distance, which is f of x plus h minus f of x, divided by this distance, which is h. Okay, so I reckon if I figure out what each of these bits is, and then I can do the limit, and that should be the answer. So let's see, f of x plus h would be what I get when I put x plus h into the formula everywhere there's an x. So f of x has got an x squared here and an x here. Both of those x's are going to have to be replaced with x plus h. Okay. And I guess it seems reasonable to expand it out. X squared plus 2xh plus h squared. That's how I expand out a perfect square. And then the minus 3 can come in here. And I reckon what I might do is put all the bits with h at the front and all the bits without h at the back. It doesn't really matter, but I just have a feeling that's going to work out well for me. 2xh plus h squared minus 3h, and then plus x squared minus 3x plus 12. Okay, I have covered everything. And then I'm going to have to do, I know what f of x is, so I can subtract them now. F of x plus h minus f of x is 2xh plus h squared minus 3h plus x squared minus 3x plus 12. That's what f of x plus h is, minus x squared minus 3x plus 12. And I had to put it in brackets so that the minus belongs to all of it. And now I can see that there's a whole x squared minus 3x plus 12 minus an entire x squared minus 3x plus 12, so they disappear. Cool. So I reckon I can sub all of this into this part of the formula now and just run with the working from there. So the limit as h goes to 0 of f of x plus h minus f of x over h. I think copying the whole thing at the moment just so that everybody knows that I'm subbing it in when I do the next bit of the working. 2xh plus h squared minus 3h over h. And then if I divide, I can divide everything by h at this point. I couldn't do that if h was 0, because 0 divided by 0 doesn't mean anything, but h technically isn't 0 because it's just going towards 0, so it's not actually quite there yet. And so that gives me 2x plus h minus 3, and I have to keep the limit as h goes to 0 there because I haven't actually done that bit yet, so it needs to still be there until I deal with it. Otherwise, I can't use the equal sign. It wouldn't actually be equal. And now I can put the h equals 0 in now that I've actually removed it from the bottom of the fraction. So 2x minus 3. And so that's what the derivative is. And I've done it by first principles using the limit as h goes to 0.